ladies and gentlemen, we're going to be moving on to 2-32. It says, represent the way that the acrobat, that will be Cecil, could move across a span of 17 feet. Mara wrote the expression shown below. For each number, if each number represents the length in feet, check that each expression could get Cecil exactly to point Bravo. Be prepared to defend each conclusion with a diagram. So as I read that, what it tells me that I need to do is I need to draw a diagram that shows whether or not Mara's expressions will move Cecil the 17 feet. And so that's what we're going to do on our paper. So we're going to start right here with this one. So we have 7 plus 3 plus 7. So this expression right here, we're going to draw the corresponding diagram. And our diagram is going to help it to prove the point whether or not he has made it to Point Bravo or not. So the first part of it is, it says that he moved 7 feet, which is a total of 7 feet. Oh, come on. Holy moly. It's not wanting to focus for me. You can make it out. Oh, there she goes. And then he also now moves 3 feet to the right. So we've gone 7, and now another 3 feet is going to be 10 feet. Once he does that, he's going to move another 7 feet to the right, which now puts us at 17 feet. So I want to be really clear about this. This diagram shows the movement, but this diagram proves that it's 17 feet because we keep track along the way of how far he is moving, the total amount. So the answers to this one here should not be the same or look exactly the same as this one up here. It should be different. So we're going to do the same thing with this fella right here, my 7 plus 10 feet. So again, my buddy Cecil, he went 7 feet, and then he went 10 feet. So once he did 7 feet, that is 7 feet long. 10 is now 17 feet long altogether. I'm going to let you do Charlie right now. Go ahead and pause it. For this guy right here, for Delta's a little different. So Cecil went 10 feet, and then he went 10 more feet, and then he now is moving the opposite direction 3 feet, because we have 10 plus 10 plus the opposite of 3. So we're going to draw that. So for this guy right here, we're going 10 feet, which is a total of 10 feet. Now we're going to go another 10 feet, which 10 plus 10 is 20. Now we're going to turn around and go the opposite way, 3 feet. So I'm going to drop down here to make it really clear what's happening. So 20, and then going the opposite direction 3 feet would bring us back to 17 feet, which is what we want. So using what we just did right here in this drawing, we need to answer echo. And echo in the textbook says, what does the opposite of 3 in part delta represent for a movement for Cecil? So we have right here where he went forward 10 feet, 10 forward 10 feet. So what movement is this right here? Many students will tell me that he moved backwards. Another response that students will use is to the left. We're not talking about subtracting yet. That's going to be coming soon, and it is more of a challenge, and so we're holding off on it. This is just the first lesson, so we're only adding here, but we are adding the opposite. And so that absolutely the opposite direction. You could also add that as well. He's moving the opposite direction. And this opposite word's important because that's what we're going to be talking about that as a vocabulary term really, really soon. So we have where Cecil is either moving backwards, he's also moving to the left if it's from my perspective, or he's moving in the opposite direction. 2-33 says, write numerical expressions similar to those in 232 for each of the solutions for part Charlie in 231. So students got really confused on this for some reason. I'm not really sure why. Maybe it's the numerical part of this, but you're writing expressions. You're writing expressions, just like there are right here. These are also expressions. But we're not doing it for this problem. We're doing it for the problem up above. So let me show you. So again, I'm going to write an expression like this. Oh, it won't let me do it on there. Oh, how funny. An expression just like this with symbols, which are numbers in operational symbols, for what we did up on Charlie up here, but I'm going to write that expression right here. So for this one that we did together, we have where Cecil moved 4 feet, and then he moved 11 feet. So what I'm going to do to change that into numbers in symbols, excuse me, because numbers are symbols. So again, with this guy right here, I have 4. And I also have 11. And because I can make the argument because we're going to the right, or also the fact that we have not changed direction, that we should have an addition symbol. So this right here is the expression for what we did right here in this drawing. So make sure that you continue to write your expressions right down here. Stop the video now and do that. Mrs. Fox, now going to move on to 2-34. So, that's the homework. Don't forget to do that. 2-34 right here, we're going to go ahead and go back to the textbook, see what the textbook says. Textbook says 234, when combining lengths to make a new length, like you did to get the acrobat across the rope, does the order of the numbers or lengths matter? Does the order of the numbers matter? So if you were in class, you would discuss it with your team and decide whether or not it matters or not, and then to be ready to explain why your answer makes sense. So we're asking whether or not the order of the numbers matter. So I went back personally to this problem right here. So it's asking right here, does 7 plus 10, does it matter if I have 7 plus 10 to be 17? Or does it change anything if I have 10 plus 7? Do I have a different value here? No, because I am adding these, even though my terms have been reversed, I still get that same value. So coming back right here, the order of the numbers does not matter because The values remain the same. Some students use the word equivalent or equal today. That's absolutely the same meaning right here. So my example that we were using earlier was on that problem where we had 10 feet and then 7 feet got me to 17 feet, and 7 feet and then 10 more feet will also have me at 17 feet. So we'll go further into the commutative property later, but just know that as you're adding integers together, the order does not matter because the value of the sum will remain the same.